Hi, I'm Ryan Nickel, CTO at DSA Ocean, and today I want to talk about doing a speed run in evaluating the ship motion affected comfort rating for a yacht. So why is this important? Well, one of the computationally intensive tasks of evaluating ship motion is the radiation and diffraction values. However, the reason for this is because there's a large range of speeds and relative wave directions and frequencies and things like that that you may not really need for the purposes of evaluating the motion affected comfort rating. So we're going to use the 50-meter generic yacht project to demonstrate this. So we've got things already set up, and in fact I've already gone through the process of calculating the radiation and diffraction values. So what I want to highlight here is we have to keep the same number of encounter frequencies. However, when it comes to looking at the wave excitation and diffraction parameters, we only need to look at a few cases. The ISO motion affected comfort rating is evaluating ship motion at 0 knots and at 12 knots. So you can pick values, or you can use a range and go 0, 12, and 12. And then it also looks at a bow quartering condition, which is a relative heading of 135 degrees. So you just really need to only have this one direction. Now, the other thing is, with regards to frequencies, it's looking at the standard requires that you look at a range of frequencies that correspond to the occurrence of 1 meter significant wave height in 2 regions in the Mediterranean and Caribbean. To cover those values, the maximum range should be 2.5 radians per second. So there's a little bit of an adjustment from the default here. But other than that, when you run through this on my sort of very run-of-the-mill commercial off-the-shelf available laptop, it's taken about 950 seconds. It's about 15 minutes to run through that. So that's not very long, especially if you're doing sensitivity studies in the design phase and you want to see what happens with different form factors of the bow and stuff like that. So those are the kinds of things you want to focus on. Let's take it through the next couple of steps though. So what you would need to do then is make sure you rerun build ship with that hull radiation and diffraction database. So this is already kind of set up for that. And we're going to rerun it. So what it's doing, what the ProteusDS Ship Motion 3D toolset's doing, is just assembling this database with all of the parameters and characteristics that for the ship motion model to generate the motion RAO that we'll use as the input for the motion affected comfort rating. We have to go to CKeep regular. CKeep regular just means regular sinusoidal waves, right? So here's where we pick that database that we just generated from build ship. And again, here we want to make sure we have those same values. Otherwise, it will the ProteusDS Ship Motion 3D toolset will complain and say, "Hey, you can't pick values outside the range of what you ran." So you just got to echo. Basically, you have 0, 12 knots, only 135 degrees. Here we want to put a maximum 2.5, and then we'll have this checkbox export ProteusDS response amplitude operators. So we'll go run. Now you can see we have this file that's generated here, generic yacht 50 meters RAO regular. So we're going to go over to the ship motion toolbox here. You will need to define the areas. Now these are defined for you for the generic 50 meter generic yacht. So first we load that RAO that we just computed here. And we'll call this under notes bare hull evaluation 1.5 meter wave height. So find that a little bit more meaningful, 1.5 meter wave height. And you'll see that the areas are all default here. Well, don't forget with the generic yacht sample files, you'll see this text file, generic yacht 50 meter areas.txt. What you can do is highlight that in Notepad and just go edit copy, or you can use Control-C. And then when we go back to here and we go paste all, it'll paste those areas in. So this is another way that you could save a couple of different configurations you might be looking at for where the areas are for the owner's cabin and all those kinds of different things. And we'll run the analysis. So this way we've got sort of I call it a speed run because you've got the minimum you need to make sure you're covering the ISO required conditions for evaluating motion affected comfort, but you're not doing more than is necessary, so you can go through this process pretty quickly. And here you can see we have pretty detailed, comprehensive information about the motion affected comfort rating for this particular configuration. All right, well, thanks very much for watching.